Okay, so here we are to discuss a very interesting and very new theme in dental education. We are talking about artificial intelligence. We are teachers here and we are facing change, and everyone wants to know what will change, what's going to be from the dental education in the future. And that's why we brought Professor Sergio Uribe. It's a specialist in the area. And if you had the chance to follow him on Twitter, you see very interesting discussions and conversations and articles. He always presenting there. Professor, it's a pleasure to have you here with us. And feel free to do your presentation. The floor is yours. Thank you very much.
Thank you. I will share my screen. Can you see it?
Yes.
Okay. Well, thank you very much and good afternoon, dear colleagues. And many thanks to Marco for the opportunity to share with you all my very dear colleagues in Brazil. Today, I have the privilege of sharing with you some of my work in the field of AI, artificial intelligence in dentistry. This revolutionary area holds significant promise for transforming patient care or incrementing, for example, diagnostic accuracy and overall healthcare outcomes in our profession. At the beginning, I wish to declare that I have no financial relationship with any of the products presented in this conference. Our discussion today is structured into 4 comprehensive sections. We'll begin by delving into the fundamentals of AI, including the cutting-edge domain of generative AI. Following this, we will explore the practical applications of AI in dentistry, while also shedding light on existing limitations. These limitations often stem from the way that we conduct research in AI. And finally, we will conclude with some recommendations and some thought-provoking questions for future exploration. In the QR code, you can download 3 publications that complement what we will discuss in this conference. The code will be displayed several times during the presentation and also at the end. And in these publications, you will find the fundamentals and applications of AI in dentistry, as well as recommendations for research and education. So, it has been almost 60 years since we began to apply computing to medical diagnosis with the pioneering works of Dr. Ludwig, where he essentially annotated images with the diagnosis so that a computer could learn how to identify the different diseases in the images. From the medical point of view, the current approach of application of AI is still the same. But now we have magnitudes of time, more computational processing power and storage than in the 60s. On the other hand, we have new and powerful algorithms that allow us to handle magnitudes of times the complexity of the data. So in the early stages of healthcare technology, we pioneered the development of expert systems. These systems require a group of experts exhaustively identify every conceivable variant for diagnostic and treatment decisions. Such expert systems are specialized programs designed to emulate human expertise in diagnostic and treatment decision making. So here you can appreciate their complexity in these 2 examples. This expert system proved invaluable, particularly in regions where, for example, expert resources were in short supply. They play a pivotal role in standardizing decision-making processes or effectively lowering misdiagnosis rates and ultimately enhancing patient outcomes. Such expert systems follow a traditional programming style, where an image is evaluated based on a set of rules determined by a group of experts to provide a potential outcome, as demonstrated here with this, for example, radiographic lesion. This is what, again, we know as traditional programming. In traditional programming system, an algorithm is fed with data and rules to generate an outcome. In this case, an image is processed with a set of rules such as lesion size, odor characteristics, or displacement of neighboring teeth, and so forth. So the algorithm takes the data and rules and produce a result. In this case, a list of probability diagnoses. The efficiency of these systems depends on how well the rules cover all possible cases. But in the early 2000s, the development of AI was primarily driven by a significant advances in computing power. Also, the availability of vast amounts of digital data and breakthroughs in machine learning techniques, especially deep learning. These factors allow AI researchers to create more sophisticated AI algorithms and applications. And additionally, increased investment in open source collaboration and the real-world impact of AI in various industries contributed to the rapid fast growth in AI technology in dentistry during this period. And this has led to an exponential growth in research into the potential of AI-based applications for diagnosis, prognosis, and treatment of oral diseases. Most of this research corresponds to those diagnostic and prognostic applications. So, let me explain the basics of AI in the next section. A common question is, what is AI and what is the difference between AI and machine learning? So, one way to think about AI is that AI is a discipline, like physics, for example. AI is a branch of computer science that deals with the creation of intelligent agents, which are systems that can reason or learn or act autonomously. Essentially, AI has to do with the theory and methods to build machines that think and act like humans. In this discipline, we have machine learning, which is a subfield of AI. It is a program or system that trains a model from input data, and that trained model can make useful predictions from new or never before seen data drawn from the same set used to train these models. These machine learning algorithms give the computer the ability to learn without explicit programming, as difference of the traditional programming, where we have to feed the system with a very strict set of rules. So this machine learning, it's a program or system that trains a model, for example, from an input data such as dental radiographs. And this trained model can make predictions from new or previously unseen data, like, for example, a new radiograph, as long as the new data is similar to the data used during the model's training. So if you feed the system with panoramic radiographs, the system will be able to process afterwards panoramic radiographs, but not periapical radiographs. So, machine learning gives the computer the ability to learn without explicit programming. There are two fundamental types of machine learning models, which are quite relevant in dentistry, especially when it comes to radiographs, and such those systems are unsupervised and supervised models. The key distinction between these two lies in the presence of labels. In the case of supervised models, we work with labeled data. You have to consider labeled data as, for example, radiographs that come with an additional information like a tag. This tag or annotation could be a name, a type, or even a number, which helps the model to understand and learn from the data. In this case, with a yellow box, there is a restoration mark on the radiograph, and with a red box is a curious lesion. On the other hand, unsupervised models deal with unlabeled data. In this scenario, the radiographs have no such tags or additional information, and they are essentially raw data without any predefined labels or categories. Here, we illustrate a scenario that a supervised model in dentistry might address. Let's consider, for example, that you have a data set containing information about a complex surgery. The y-axis represents the time that it takes for a patient to recover after the procedure. And in this supervised learning, the model learns from historical cases to predict future outcomes. In this case, the recovery time for the surgery. The model uses surgical time as input to predict an expected recovery time for future patients that use or not a new antibiotic. And this is an example on how a supervised model in dentistry can make predictions based on past data. And now, this scenario illustrates a problem suitable for an unsupervised model. So imagine you have data related to dental patients, specifically their level of caries and their family income. Your objective here is to group or cluster these patients based on these factors to uncover any underlying pattern. Here in unsupervised learning, the model aims is to discover the hidden structure within the data. It analyzes the raw data, which includes, for example, the level of caries and the family income, to identify whether there are any natural grouping or cluster emerging among the patients. This process enables the identification of trends or categorizations that may or not be immediately evident for the clinician. So let's delve a little deeper and illustrate this graphically. As a solid grasp of this concept forms the bedrock of your understanding of the more modern applications of AI, as for example, generative AI. Here in supervised learning, we input testing data values, in this case referred as X's, into the model. The model then produces a prediction and compare it to the training data it was initially fed. If the predicted data values differ significantly from the actual training data values, we call this difference error. Now, the model's objective is to minimize this error, ensuring that the predicted and actual values converge. This process is essentially a classic problem of optimization in AI. On the other hand, in unsupervised learning, there is just, after we input the data, the model generates an example with this. So now that we have discussed the distinction between artificial intelligence and machine learning, as well as supervised and unsupervised learning, let's take a moment to discuss about deep learning and how it fits into the landscape of or as a subset of machine learning methods. Machine learning is a very diverse field encompassing various techniques, and deep learning is one of such type of machine learning. Deep learning leverage artificial neural networks, enable them to handle more or very complex, intricate patterns and data than traditional machine learning methods. Usually, machine learning is used for structured data, as for example, clinical files stored in a database. Meanwhile, deep learning are used for non-structured data or very complex data, for example, radiographic images from CBCT examinations. So, while machine learning encompasses a very wide range of techniques, deep learning represents a very specific category within machine learning. Here, deep learning usually utilizes artificial neural networks, giving them the ability or capability to analyze and understand more intricate and complex patterns compared to conventional machine learning methods. So these artificial neural networks draw inspiration from the human brain, consisting of many interconnected nodes or neurons capable of learning tasks through data processing and predictions. Here, the deep learning models, in particular, feature multiple layers of neurons, enabling them to grasp very intricate patterns beyond the capabilities of traditional machine learning models. These neural networks can work with both labeled and unlabeled data, and a technique known as semi-supervised learning. In this approach, a neural network is trained using a very limited amount of labeled data alongside a substantial amount of unlabeled data. While the labeled data aids the neural network in grasping the fundamental task concepts, the unlabeled data enables it to generalize to new unseen examples. And here, generative AI, that is what everyone is talking right now, falls within the domain of deep learning. This implies that it leverages artificial neural networks and possesses the versatility to handle both labeled and unlabeled data through supervised, unsupervised, and also semi-supervised learning techniques. So maybe you have seen, you have heard about ChatGPT or Bard or Google Search. Those are examples of large language models that are a subset of deep learning as well. So these deep learning models, including machine learning models, can be categorized into two main types: the generative and discriminative models. The discriminative models are primarily used for data point classification and label prediction. For example, caries yes, no, or in the future, cancer yes, no. They are trained on labeled data to learn the relationship between the data points, features, and their corresponding labels. Once trained, they can predict labels for new data points. On the other hand, the generative models are designed to create new data instances based on a learned probability distribution derived from existing data. The main idea here is that generative models have the ability to generate entirely new content. Consider this example. Here, the discriminative model learns the conditional probability distribution, which means it calculates the probability of Y, our output, being a Baldwin radiograph given X, our input. Being able to distinguish this, for example, from a panoramic radiograph. And in this case, it gives correctly the label of Baldwin radiograph. In contrast, The generative model learns the joint distribution probability, which calculates the probability of both X and Y, or input and output. In this case, it predicts the conditional probability that this is a bite-wing radiograph, and because of this, has the capability to generate a new bite-wing image. In summary, generative models can create new data instances, whereas discriminative models distinguish between various types of data instances. Here, the top image illustrates a traditional machine learning model, which aims to understand the connection between the data and the label. For instance, what it needs to predict. And meanwhile, the bottom image illustrates a generative AI model which strives to uncover patterns in content, enable it to produce fresh or new content. In summary, in traditional supervised and unsupervised learning, these techniques involve using training data with labels to construct a model. For example, labeling radiographs to enable the model to predict or to identify dental caries. Depending on the specific use case or problem, the model can provide predictions or classify items or cluster data. And now we use this example to illustrate what a generative model process. Unlike traditional methods, here the Gen AI can utilize training code, labeled data, and also unlabeled data of various types to build a foundational model. This foundational model can then generate diverse content such as text, code, images, audio, video, and so on and so forth. This is a significant advance from traditional programming to neural networks, and of course, this is what everyone is talking nowadays. Here, for example, are the output of two generative AI systems, specifically two large language models. One is OpenAI ChatGPT, and the other is Google Bar. And after asking about what a dental implant is, what we observe here is an AI model that constructs sentences by placing tokens or pieces of text one after another. These placements are guided by statistical probabilities. And this is the most important concept. This represents a probability that some piece of text or some word comes after another. And these probabilities are determined by the model's training data and of course, the underlying architecture. This is why, under the same question, two different models generate different answers. Here in both, the model predicts the most likely next token based on the sequence of tokens or words that is already generated and the context that it has been given. The end result is very coherent and contextually appropriate for the question given. And this was generated in real time, offering explanations that are factually grounded most of the time, but very often indistinguishable from a human expert response. So now we have laid the foundation by understanding the fundamental concepts and gaining some insights into various machine learning and deep learning models and generative AI models. Now we will examine some practical examples in the field of dentistry. Here, for example, we see an application developed in Germany by the team of the Charité in Berlin, where the system is fed with a panoramic X-ray. Here, the model is trained to perform various tasks. On one hand, it estimates the bone level, which you can see in the purple line. Additionally, It can fill a dental shot, identify present and missing teeth. You can display the visualization of the layer. And moreover, the system identifies the condition of each individual tooth, completing the information on the chart that you can see at the bottom of the screen, where you can see how it identifies filled teeth, implants, and also suggest areas where there might be some caries lesion. There is an implant, there is a filling, and there is a potential caries. Here is a potential closeness between apex and mandibular canal. And here you can see an application developed in Chile by BAS Corporation, featuring a very simple interface. In this case, I upload a Bituin X-ray, and the system within seconds identifies areas with caries lesion by marking them with boxes. These are two examples of how AI system can process images. Another example is the estimation of bone age, for example, with wrist X-rays. When an algorithm reaches an estimation accuracy of 8 months with respect to the real age for both sexes in less than 2 seconds, as shown here. Here, in this case, this algorithm was the winner of the annual artificial intelligence competition held by the American Society of Radiology. Less than 2 seconds. But AI not only serves to diagnose, but can also be used to perform repetitive tasks, such as, for example, locating cephalometric points, as shown in this lateral teleradiography. In this case, we upload the radiography, and the system automatically mark each cephalometric point and can give different exam like Steiner and so on and so forth. Additionally, these applications can be put and integrated into other devices. For example, here is an application that uses a smartphone camera to identify potential
When finding a suspected lesion in oral cavity, we can take out a smartphone outfitted with the developed deep learning algorithm to do a fast examination. After opening the app, we firstly take a photograph for the suspected area, and then processing this picture on the algorithm. Few seconds later, the result comes out. When finding a suspected lesion in oral cavity, we can take out a smartphone outfitted with the developed deep learning algorithm to do a fast examination.
So, here we have showcased some applications as a few examples of AI has the potential in oral healthcare. However, like any healthcare application or intervention, it is imperative to evaluate the scientific evidence supporting the efficacy and reliability of these AI-driven applications. At this moment, there is a wealth of research in the subject, synthesized in over 50 comprehensive systematic reviews. And this is a very recent review, some few days ago, that is actually an overview. It's a systematic review of the systematic reviews that in this specific case evaluate some AI models for the analysis of panoramic radiographs. And in all of these systematic reviews, we consistently see high levels of diagnostic accuracy. At face value, one might conclude that AI applications are both effective and useful for diagnosis of oral conditions. However, this picture is not entirely as optimistic as it may appear. And let me explain why. Also in a systematic review that we performed with a group of researchers from the technical office of the United Nations called ITU, we explored the evidence supporting the use of AI for caries detection. And we found that all studies report very high levels of diagnostic accuracy, but very few of them report who annotated the images or which criteria was used for the annotations. And maybe more important is that only one study has used a validation dataset. And let me explain the importance of this. These are the results of the different studies. And as you can see in blue, there is the only one study that used a training dataset. Let's consider how these models are trained. In this case, we use a data set that we divide in two, usually a large data set that we use to train the system, and a smaller part that we use to test the performance of the system. When we found that, for example, the model doesn't perform very well, we adjust some of the parameters or change the features of the model, and then we train again, and then we test again, and we do this process until we achieve some level of performance. Afterwards, to really check what is the performance of the model, we need to check or evaluate the performance in a validation dataset. This validation dataset can be part of the original dataset, but usually should be a dataset obtained from a different center, for example, or prospective in the future, because we have to ensure that the algorithm haven't seen this data before. For example, here we can simulate this as, for example, for students taking exams. We let the student to make the test. Afterwards, they see the answer, and afterwards they can correct the test. Will be useless if we use the same test one and over again, because we can create the false illusion of performance of the students, because even if the students maybe are not learning anything new, they are just learning the correct answers that they have to mark on the test. This is the same what happens with these algorithms. So when you read any paper about AI, you have to ask the paper where this performance was validated. Was validated in another center or with prospective data? How we can be sure that the algorithm wasn't able to see the data beforehand? And additionally, the choice of the metrics what we will call as performance can lead to misunderstandings. At present, most AI research papers in the field of dentistry focus on reporting metrics related to the technical development of the models. While these metrics are critical for the fine-tuning of the model technical performance, they do not necessarily provide insights into the potential impact of these models could have on actual clinical outcomes for patients. In other words, achieving high scores on technical metrics do not automatically equate to effective or safe clinical applications. Here, you can see some of the metrics that future AI studies should report. These metrics are geared towards evaluating the clinical impact of AI models applications. For example, what we hope to see in research is whether these models influence clinicians' diagnostics or therapeutic decisions. For example, what happens when the model makes an error? Does the clinician correct the decision, or do they adopt the AI model's criteria? We don't know that yet. Moreover, it is essential to assess the impact of these models on patients. And these fundamental questions are, do they improve health outcomes, reducing the prevalence or severity of other diseases? Or, on the other hand, the application of these AI models could lead to overdiagnosis and overtreatment. And what will be the societal impact? Will it lower healthcare costs or increase them? Will it expand or reduce health coverage in the populations? These are the questions that future research must begin to explore. To address this concern, along with a group of researchers, we have developed a checklist with recommendations for the design and reporting of AI publications. This checklist can serve as a tool for assessing the quality of published reports, as well as for planning or designing and reporting research for those who are considering investigating in AI in dentistry. And finally, what we should consider, we should consider that also there are some ethical and legal issues. And I have followed very closely the development in Brazil, because Brazil is one of the few countries that has proposed some laws about AI. And for what is my understanding, the Brazil AI law is a result of 3 years of legislative efforts emphasizing user rights and AI risk management. For user rights, the law prioritizes user rights, requiring AI providers to disclose information about their system. So the users have the right to know when they are interacting with AI and to receive explanations for AI decisions. And this is, I will say, a big issue, because AI nowadays works as a black box. We know what enters, we know what it comes out, but we don't know what happens in the middle, how the AI takes the decision, because these neural networks are quite complex. About user protections, the user, according to the Brazilian law, can challenge AI decisions and request human intervention, particularly in high-impact areas, such, for example, in credit evaluation and healthcare. And there are risk assessment and also developer liability. In this case, all AI developers are liable for damage caused by their system. And this is something that will be interesting to see how it develops, if it limits or expands the application of AI system in Brazil. And about healthcare, there are two key problems in dentistry. The first one is how to translate the research findings for practical clinical use, and how to decrease the cost to increase the coverage of population. If you see here, the care costs are continuously rising, leaving groups of people without coverage. So it will be unfair to attribute this increase to technological innovations, because in practice, what has happened is that a significant part of this cost increase could be explained by the different administrative layers that have been added in the last decades in patient care. And this, I believe, is where AI applications should play a more active role, not only at the clinician side, collaborating with the diagnosis, prognosis, or treatment of patients, but also improving the administrative efficacy in healthcare. So, an AI application focused on reducing administrative cost could have a lot of more impact on improving coverage than for example, an AI application focused on diagnosis, which may be not available to a part of the population. So, how do we measure the value of an AI application for dental practice? And for this, we must consider the goals set by the World Health Organization. And in dentistry, the goals are twofold. Firstly, to achieve 75% of universal coverage, and secondly, to reduce oral pathologies by 10%. Those are the two key metrics that anyone should have in mind when reading or planning or reporting AI applications. So, for example, perhaps would be appropriate for every developer, every engineer, every healthcare professional, or anyone involved with the development of these AI models to consider how much do you expect your new AI model or application can increase the universal health coverage, or by what percentage they expect to decrease a particular oral pathology. I am certain that the development of artificial intelligence will significantly impact the way we treat and interact with patients. However, how do we ensure that these technological advancements not only improve efficiency, but also enhance the quality of healthcare and preserve the integrity of the patient-provider relationship? And what will you, as a clinician or educator or researcher, will do to achieve this end? Thank you very much for your time.
Thank you very much, Sergio. That's really good. I was thinking about, and I was talking to Professor Daniela, and she was asking to ask you to make any other considerations about the ethical implications of this kind of error that an app can cause. Or I saw the one that you showed that it doesn't show the type of cancer or any, it's just a cancer alarm. It's very generic. I believe that that's the reason, but can you go in deeper in this subject, please?
Yes, thank you for your comment. Indeed, these models usually requires a lot of data, and the quality of the data is crucial for the development of this model. we have seen what we have seen is that much of the data generated to feed these models is data that has been taken from the hospitals. But the problem is that the data stored, for example, in the clinical files of the hospitals, is not data used for the clinicians. This data is usually stored for administrative purposes or for insurance purposes, to see how many syringes we use, how many medicaments we use. But most of the time, when, for example, when a physician goes to see a patient, they talk with the nurses, they talk with the patient, and this information is not stored in the clinical file. So this is one of the problems that we have about the data that we are using to train these models. This is one of the things that we should, in one way or another, we should improve. Because the data that we usually have, for example, during the recent COVID pandemic, more than 600 prediction models, machine learning prediction models were developed. Of these 600 models, none of them were proved to have any clinical utility. Why? Because they use, for example, one model learns to predict the severity of the COVID, if the patient will have very severe COVID or very light one. And the data, the performance shows that with a 95% accuracy, the model can predict who will have a very bad case of COVID and who's not. The issue is that it learns with the radiograph of the people. And the people who arrive to the hospital arrive in two conditions: in very bad shape, and they cannot even stand, so they have to take the radiograph in lying in a table, and there were some metal in the table. Or the patient, if it's not grave, can be stand up and a radiograph was taken. So actually the model learns how to detect these metal indicators on the radiographs, but it never predicts really the gravity of the COVID or predict anything at all. Indeed, it learns that the worst cases were taken lying and the light cases were taken stand. And this is the issue with the data. Anyway, this paper you will read, and you will read machine learning model detects or predict the COVID case with 99% of accuracy, but it's not the case. So I will say that to develop AI, you need three components: data, an algorithm, and computing power. Computing power is not in our hands, is NVIDIA, IBM, and so on, these companies. Algorithms is an engineering task. The only thing that we as clinicians can provide or can use to create these applications is good clinical data. And this, even with the amount of data that we have the data that is created in hospitals, mostly is for insurance, for payment companies, and not for clinical use. So meanwhile, we don't have this very good clinical data. We will see that these models in real life applications doesn't perform well, as you see in this case.
Yeah, see, I think you just answered the next question. I understand that there in Latvia you have a health system similar to the British one that's similar to Brazil as well. And my question was, how far are we from use this AI models to predict what's going to happen with our population? So in here, we have a lot of discussion about trying to put all the data from the patients in electronic promontory and electronic record and everything. But it's a huge country. It's difficult for us to have this in one state, even in one city. We have here also AI with Watson, for instance, can read sample diagnosis from blood and everything. Of course, we have a physician to sign the exams, but we have Watson doing this here already in main companies. But I mean, in the health system, the national health system, how far are we from using this? I mean, with data.
Well, thank you again for your question, and it's very nice that you mentioned Watson. Because Watson was actually discontinued by IBM and was sold by pieces afterwards. Because again, the problem is the data that we are using to feed this system and to train this system. For example, specifically with Watson, if you put data in Watson, the main problem is that this system doesn't understand the context, and context in clinical care is everything. So two blood level samples with the same indicator, some measurements, the same level in one patient can be that the patient will have a survival rate of 95% in 5 years, and in the other patient, the same level can predict or can represent a 5% of survival in the same time. What's the point? What's the difference? Because one test was taken 3 p.m. in the afternoon, so it's a usual care, and the other one was taken 3 a.m. in the night. Who are taking blood tests 3 a.m. in the night? A very ill patient. And this context is not was not understood by Watson in this specific case. Also, it's a problem of portability or generalizability of this system. There is a very nice research by Falk Schwendig and his group of the Charité, when they train a model with radiographies from Germany, and then they test how they perform with radiographs from patients from India. And they see a very marked decrease in the performance. So that means that such systems require, as well as the food, some kind of labels where it indicates clearly in which patients were trained this system, what were the characteristics, the demographics of the patients used to train some specific system. So you can see the label in the model and then compare with the patient that you expect or the population that you expect to use this system to prevent any misalignment between the data that was used to train the system and where you will use the system. I'm very sure that with the correct alignment between this. For example, I'm very sure that Brazil or any country there will be no such thing as a big AI system that will be reign over all. I'm very sure that we will have a lot of specific system. For example, Brazil will have their own specific AI system for healthcare, and inside Brazil there will be different subsystems that will be specifically trained for some specific population.
Thanks. It's open for questions if anyone wants to ask something. We have one question here. Two. Just 1 second. Professor Paulo Reis is asking, what is your perception about the use of AI during the undergraduation in dentistry? And what would be the best way to implement it, if it's the case?
Yes. Well, thank you very much for this very thought-provoking question, because one of the things, I have been an educator for all my professional life. Okay, so I'm on the academic side, and one of the things that I think everyone should agree is that the COVID pandemic showed us how ill-prepared we were to adopt these technological tools. I remember in one of the universities that I work that they were discussing to make this, to implement IT classes and everything and so on and so forth. And they say, oh, but we require a lot of money, a lot of instruction, how to use this system, etc. And then COVID arrived, and in less than 2 weeks, everyone were doing this. So we were forced into this. So for some reason in the academy, we are always reactive and we are not preventing this. We are not very proactive. And I think the same happened nowadays with these AI tools. What will be the future, for example, for essays, written essays, for example, if we have tools like ChatGPT that can create a professional grade essay in seconds? What will we, I don't know. We recently and this is in under review, researched what were the views of the academic staff about AI in education. And most of the answer were that this is very interesting, but there is no idea how to implement this in reality so far. And so we need a group of people to sit down and examine the pros and the cons of these tools and give us some guidelines about how to implement this. We recently published in the European Journal of Dental Education a paper with some recommendations about how to implement AI, how to teach about AI. But we don't have yet some clear guideline about how to implement AI during the education, how we can use it. Anyway, OpenAI, the company behind ChatGPT, has recently published some recommendations for educators. I'm very sure that such recommendation could be adapted to dental school. And in my view, I believe this will be very similar to what happened when the calculators appeared some decades ago. Because some teachers say, but this will, I mean, the mathematics will change, and some teachers were very upset because they thought that if the students do not make the calculation by hand, they will forget how to think, they will forget everything. But actually what happened afterwards is that the use of calculators has, I mean, everyone should agree that an engineer student nowadays knows the same or more than a student in the era that a rule-based calculator were used, or even before. So I think we should use these tools wisely. I don't know exactly how, but as soon as we started to use, we can see the limitations and also the opportunities that it gives to maybe to use the time in class to discuss, to use more proactive or more wisely the time that we have with the students, maybe. But this is a thing that I don't have clear answer, because everything is being very, very fast in developments. But thank you for the question.
Yeah, thank you very much, Sergio. We have other questions here. Let me just say something. Paulo, eu uso todo dia com meus alunos a AI na sala de aula. Eu trabalho com os alunos do primeiro ano e eu uso para que eles consigam entender casos complexos que eles ainda não aprenderam nas outras disciplinas. Então fica mais fácil para eles entenderem aonde está a aplicação da básica. Então é o que o Sérgio está falando, né? Para acelerar tempo, né? Sérgio, we have other questions here. For instance, this one from Professor Fontanella. De 6. Pensando en la educación odontológica, me parece que nuestro gran desafío es ayudar al estudiante a ser capaz de formular las preguntas correctas y evaluar correctamente el producto de diferentes herramientas basadas en inteligencia artificial. Me gustaría escuchar tu opinión.
Well, thank you for the question. If we see the development of dentistry as a science in the last years, since the end of the 90s, we had the development of ABENO-based dentistry. I think we are still far from implementing correctly the principles of ABENO dentistry in dental education. I don't know which proportion of students graduated from dental schools are capable or have the skills to critically search and appraise the dental literature. I believe is less than 50%. So meanwhile, we have this gap in the critical skills of the students. I think we will not be able to fully integrate AI for dental education, because the most important skill that we should teach to our students are the critical appraisal skills, how they differentiate the facts from opinions. We saw that during the recent COVID epidemic, the World Health Organization declared that we're also an infodemic. And most of the people were, even health professionals, were unable to distinguish between proper, well sound and validated information from opinions. And now, with AI, maybe this problem will increase. So I strongly believe that this is a wake-up call to reinforce the teaching of critical skills of literature appraisal in our students. I think the most important skill that we can teach to our students today is to differentiate the facts from opinions.
Sergio, I know it's late there. We have just one last question. Is it okay?
Absolutely, please.
Okay, so it's from Regina. One sec. She is asking, your opinion, what are the strategies that you suggest to overcome the resistance of teachers, students, and professionals to the implementation of AI and the use of digital tools for learning, clinical practice, management, etc., etc., etc.?
Thank you. This is a very good question. I believe that if I know the answer, I will be dean of the university. Because, you know, the fact is that Newton discovered the third law. That means that for every action is a reaction in the opposite direction and with the same force. So when you try to implement something, you have to expect this opposition, because the resistance to change is something natural in humans. We try to use the same clothes every day. We like the same football team. We like the same ideas. We love our own ideas, and we don't like the ideas of the other people. And this is a fact. So, how to? I really don't know. I would love to. Actually, I would love to hear your opinions about this, because I don't know. I have been teaching evidence-based dentistry since the year 2000, and still most of my colleagues say, "I don't know, evidence. What really matters is experience. This, my hands, not what a paper said." But this is, I mean, this is the way the things are. So I would love to hear your opinions, how you deal with this problem, because I still don't have an answer for that. So sorry for that. But I would love to hear your opinion, Marco, and also Professor Regina, and all the rest.
Okay, does anyone have anything to add? Yeah, for me it's difficult as well. For me it's difficult as well, so if I know that, that would be very good. I think, yeah, Professor Vena is just saying, on time you will tell.
Usually, you know, there is a curve that shows that there are early adopters, there are people who is kind of more there are people who is naturally adopting new things. They change computers, they change operating systems. There are many things that they are able to change without any issue. There are other people that are very conservative. The thing is that the students, in some or other way, understand this, and they adapt to the different situations. So I think we, in the dental education, we are quite conservative, and we adopt some treatments or things after they are very well consolidated. This is the way we are. But in this case, AI has come and will stay with us. And this is something that is a fact. Your students this year will use ChatGPT, will use Google Bard for their studies. How you will deal with that, this will be up to you.
Yeah, you're right. You're right. I think that's it as well. There's no way to run. It's there, and it's forever. Okay. Regina, okay. So, Regina is here.
Eu tentei colocar aqui umas respostinhas para ele.
Okay, just one second. Yeah, she's saying that they are trying to do lectures, they are trying to do promotional videos, they are trying to talk to the students and trying to convince them. But yeah, it's a hard task. It's difficult to do that.
Yes, but also you have to consider that maybe this system will also help you as an educator. For example, will be easier to grade students, will be easier to prepare syllabus, will be easier to fill formularies, forms, will make easier to perform administrative tasks. And I mean, there are many different dimensions that we haven't discussed in detail, but I think that overall will be positive. This is my perception.
Yeah, some might say that with time, AI might convince everyone to do that as well, isn't it?
Yes. Indeed.
Okay.
But you know, you in Brazil has an edge, because actually the legislation that Brazil has imposed, I will say that is quite interesting. There are few countries that has such legislation so far. For example, Israel and Japan are quite liberal in this aspect. European Union has been quite, I will say, tight, because they say quite the dangers more than the benefits. On the other hand, in the States, of course, they prefer the profits, and they leave the experimentation and the development of these applications that the market will decide. In Brazil, on the other hand, has taken, I will say, the path in the middle. And this is interesting because, for example, it's interesting that the patients have to know if they're interacting with an AI system. I mean, a dentist, when they use an AI to analyze a radiograph, should inform of this to the patient. And I think will make all the process, all the clinical process more transparent, maybe. So it will be interesting to, and I'm looking at Brazil specifically, and I'm very looking forward to see what will happen there, because it will be interesting. In Chile, here in Latvia is the European laws, but it will be interesting to see how the things develop in Brazil.
Yeah, definitely for us as well. Sergio, thank you very much. It was great to have you here with us. It was very informative, and yeah, it's always good to talk to someone that likes doing what's doing. Thank you very much. Thank you for your time. I'm sorry about the time there. Yeah. So
please, no worries. It was my pleasure. And big cheers to my very dear colleagues in Brazil. It was an honor, and I will be happy to receive your comments, emails, and so on.
So I was talking to Prof. Damien just before the presentation. He said he couldn't join, but he sent his regards. He's in another conference. You know, he likes you, so all the best, Sergio. Professor Daniela, feel free.
Okay. Well, just to say thank you so much for your presentation and for your time. It was a pleasure have you here at night, and until next session. Right, Marco? Thank you so much.
Thank you very much, Sergio. If you want to have some few words, that's fine.
Thank you very much. It's an honor. All the best.
All the best, Sergio. Boa noite a todos. Good night, everyone. Thank you for being with us. And see you next month.